Hello everyone and good afternoon. Dear authors and invited guests, welcome to Technical Session 5C. Myself Adesh Bazare and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India. The virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Now, just before we start the session, I would like to introduce you all to the chair for this session, Dr. Shailesh Pramod Bendre. Sir currently serves as the head and associate professor at NBN Siagat College of Engineering, Pune, with over 12 years of academic and industrial experience. Dr. Bendre has contributed extensively to research in AI, cybersecurity, IoT, and software-defined networks, with numerous publications and Best Paper awards. He is also recognized for guiding winning teams in prestigious hackathons like Smart India Hackathon and Ethereum ETH India 2023. I request Dr. Shailesh to share his opening remarks with our presenters.
Am I audible?
Yes, sir, you're audible.
Okay. Thank you for such a nice introduction. First of all, I would like to welcome all the participants for this conference. Hope you all will present your work nicely and we'll have a good conversation on the work, whatever you are going to showcase in this conference. Thank you.
Thank you, sir. The next paper title to be presented is Deep Tune Network, an approach towards music classification and recommendations, which will be presented by Arunab Baroa.
Yes. Am I audible?
Yes, sir, you're audible.
Okay. So I can start my presentation, right?
Sure, yes.
Is my screen visible?
Yes, sir, your screen is visible.
Okay. Is it still visible?
Yes, sir, it's visible. You
Okay.
may
Yeah.
proceed with your presentation.
Okay, great. So good afternoon, everyone. I am Arunab Barua, and I'm excited to present our research titled Deep Tune Network, an approach towards music classification and recommendation, which is done in collaboration with Dr. Saranya Rubidi. So these are the topics which I'll be going over today. Let me start off with a brief introduction. The digital music industry is a huge industry, projected to reach almost 46 billion USD in value by 2029. With enormous digital music libraries now accessible at the tip of your fingers, sophisticated systems are essential for organizing and recommending content. Companies like Spotify, Apple Music, and YouTube Music are still leading in this pole position due to their spendings on cutting-edge technologies as guarantees for users to listen to music they like all the time. I'm here to give a glimpse on how technology can help us bring people closer to music, which they like. So our main goal was to build a deep learning system which can understand the music the way humans understand and provide tangible results such as classification and recommendation of music. This is where Deep Tune Network comes in. It does three key things. Classifies music genres automatically from audio signals, learns acoustic features using melt frequency cepstral coefficients or MSCCs, and use convolutional neural network CNNs for learning temporal and spectral features from raw audio data. And finally, it recommends song by comparing how similar they sound using cosine similarity. Coming over to the next slide, we have used the well-known GTZN dataset. It has 1,000 audio clips, each 30 seconds long, covering 10 different music genres, which are listed as below. So this raw audio input then undergoes some pre-processing step. First, we convert it into MFCC spectrograms. These spectrograms show how sound changes over time, capturing both the tone and the rhythm. Then these MFCC features undergo standardization so that consistency can be maintained across the dataset. And finally, data augmentation techniques such as time stretching, pitch shifting, and noise injection are applied to make the data robust and fit for various different scenarios. Now let's walk through the architecture of the DTN. The audio input provided by the user gets processed, and then the data passes through 6 different convolutional layers and 1 output layer, which can be seen in the picture. So each layer acts like a filter. Some detect short, sharp beats, while others recognize smooth melodies. Together, they capture everything from rhythms to harmonics. Each layer builds on the previous one, helping the model learn increasingly complex musical features. Each convolution layer also includes some refinement techniques, such as batch normalization, which is used for normalizing the inputs in each layer, max pooling, which is a technique used to retain only the most important features, and dropout, which is used to prevent overfitting. So after all these layers, the network flattens everything it has learned into one final decision process and confidently pick one of the 10 genres available. Beyond classification, DTN also recommends songs. This recommendation strategy includes computing the feature vector of the song, computing the cosine similarity with all the other songs present in the database, and rank the songs by similarity score and recommend the most similar songs. So how does DTN compare with other approaches available? So we have tested several other alternatives. The first one being the MLP, or the multi-layer perceptron model. So this model struggles with complex temporal audio patterns. It also tends to overfit and lack spatial awareness. The next model we tested was the KNN and the random forest models. This model depends heavily on manual feature engineering. It also has poor scalability with large data sets. The next one which we tested was RNN LSTM model. This system can model time sequences but are computationally intensive, and thus it is difficult to train. So DTN stands out because it learns directly from the audio data. It captures both local and contextual features using convolutional filters, and it generalizes well to new songs. Also, if you pay attention to the right side of the screen, the test scores for DTN far outperform models like RNN LSTM and the MLP model. So DTN achieves a high accuracy of 93.01%, followed by the RNN LSTM model, which has a much lower accuracy of 61%. And at last, the MLP model, which has an accuracy of 59.2%. Going to the next slide. So the results for DTN were very promising. Maximum test accuracy of 93.01% was achieved. Validation accuracy reached 93.19%, and training accuracy reached 89.51%, which indicates strong generalization and no overfitting. Loss values also steadily decreased. Also, compared with the MLP and the RNN LSTM models, DTN had a faster convergence and more stable and consistent learning curves, as depicted by the graph. Also, the recommendation strategy had a high similarity score of 0.85, which suggests that the songs recommended were quite similar to the type of the music the user likes. And here are some of the comparison with existing research. And of course, there is still room for growth. Some future directions which we are exploring include subgenre classification for more fine-grained recommendations, combining acoustic data with lyrics and contextual data like mood, artists, etc. Optimizing the model for low latency and on-device performance, and adapt recommendations dynamically based on the user feedback and interactions. So to sum it up, DTN classifies music by listening to the audio. It doesn't just rely on the metadata, but it uses MFCCs and CNN to understand the music data. It also achieved a very high accuracy and outperformed several other ML models. It powers a practical recommendation system using cosine similarity. And this makes DTN highly suitable for modern music apps where both discovery and personalization matter. These are some of the references, and thank you.
Dr. Shailesh, are there any questions from your side?
Yes, can the author go to the result slide?
Yes, definitely. It's visible, right? The screen?
Yes, thank you. Slide is visible as of now.
Yeah, this is the result.
Previous one before that.
You mean this?
Yeah, this one.
Yes.
So you have compared these three models, right? Deep
Yes.
Tune Network, RNN LSTM model, and MLP.
Yes.
So did you got any analysis why your Deep Tune Network is working better than what other networks are available you use for your processing? Any justification for the same?
Yes. So basically, what happened is I built out all the three models and I ran it on my system. So basically, what I noticed was that RNN LSTM models and the MLP model, it has a lower accuracy than the DTN model. This is because of some issues with inherently, which is present in the model itself. So the way it works is basically it doesn't is not able to classify music as the input. This is the main input is music, so it's not able to classify that properly. It's not able to understand the inherent like qualities of the music. So and in that regard, deep tune network I found was very more accurate.
Uh, Means I just wanted to check that since all are your deep learning models, right?
Yes,
So did
yes.
you change any hidden layer values due to which the performance has increased, or you kept the hidden layer values same for all the three models?
Oh no, they were different. So basically, what I have done is like I have tried out different combinations on how the hidden layer values interact. So basically, what the figure represents here are like the best accuracy which I've achieved out of all the three models by putting different hidden values.
Okay, thank you. That's all from my side.
Okay, thank you, sir.
Thank you, sir. We move towards our next presentation, which will be presented by Tanuja R. Patil on a paper classification of brain images using bit plane approach.
Okay, am I audible and is it visible, sir?
Yes, ma'am,
Yes,
you are
ma'am, you're
audible
audible and visible too.
Okay. So good afternoon, everyone. So today I'll be myself, Tanujar Patil. I'm working as Associate Professor in the Department of Electronics and Communication, KLE Technological University, Hubli. I am going to present my research work on classification of brain images using bitplane approach, and my co-authors being Ms. Samiksha Dangal and Dr. Vishwanath P. Badigar. So the contents will be introduction, literature survey, problem statement, objectives, system architecture, methodology, results. So brain tumor is a mass or growth of abnormal cells in the brain. Many different types of brain tumors exist. Some brain tumors are non-cancerous, say benign, and some brain tumors are cancerous, malignant. So different imaging technologies such as MRI, CT, and PET are being used for taking the brain images. So now most of the detection and diagnosis methods depend on the decision of neurospecialists and radiologists for image evaluation. But sometimes they are prone to human errors and they are time consuming. So the main purpose of this project is to build a robust model that can classify if the subject has a tumor or not based on brain MRI scan images and classify them in different types. So different types of brain tumors are generally pituitary, glioma, meningioma, and some are no tumors also. So as per the literature survey, as per the authors, they have used many deep learning and convolutional neural networks. So as per the first author, they have found, they have used the CNNs and they have used 7 layers and they have achieved around 99.2% of accuracy. And the authors of brain tumor classification using texture feature extraction, they have used segmentation based on threshold technique and they have identified 12 features. Based on the texture features, they are doing the classification and they have achieved around 95% accuracy. And in brain tumor MRI images identification, as proposed by Ramdas V, they have used recurrent convolutional neural networks and they have achieved around 95.17% accuracy. And the VGG unit they have used and they have achieved around 95% of accuracy. So from all this, we have seen that we can use the deep learning models and convolutional neural networks or any other neural networks for this one. But what is required is, and most of them, they are using the GPUs and it is time consuming because they are using many epochs and all. So it was required to design and develop a low complexity algorithm for pre-processing, segmentation, feature extraction, and classification, and also to compare the results with the existing deep learning models. So we have started this project by selecting the brain tumor images as shown in the table. That is, we have selected no tumor around 395, glioma tumor around 826 for the training data set. And for the testing data set, we have used 105 for no tumor and 100 for glioma tumor. And as shown, in total, we have used 2,870 image sets for training data set and 394 for testing data set. And these are some of the tumor images. We can see here that is the glioma tumor. It occurs mostly in the spinal cord. Initiates from the spinal cord, and meningioma tumor, it occurs around below the skull, and pituitary occurs below the pituitary gland. And these are some more images of the glioma tumor, meningioma tumor, and these are with no tumor, and these are pituitary tumor images. So objectives of this project is to detect the brain tumor from MRI image dataset and to classify them as pituitary, glioma, meningioma, or no tumor. So our system architecture goes like this. That is the brain images training data set. This will be the input and pre-processing is done, then segmentation is done, then feature extraction, then classification, and finally the results. So the methodology involves pre-processing, segmentation, feature extraction, and classification. So what we'll do in pre-processing are, initially all input images are of different size. So we'll convert them into 512 by 512 pixel images to bring the uniformity in processing. Then the pixel values below a threshold value of intensity value 4 are converted to pure black to achieve denoising. So these are some of the images to show the denoising of images. That is this the glioma tumor, and after denoising, we'll see like this. That is the below 4 intensity value, they are all converted to black. So any noise exists that will be removed here. And this is meningeal tumor and so on. Then comes the segmentation. So in segmentation is also very simple. That is a threshold of pixel intensity value 128 is chosen for binary segmentation. The values above 127 are all converted to 128 and below 128 are converted to 0. So by this we'll achieve a pure binary segmentation. So grayscale images are represented with 8 bits. Hence, the original image requires 8 bits per pixel. The segmented image requires only 1 bit per pixel, 8th bit plane only. So in spatial domain, processing an image and taking 8th bit plane as segmented image is an important step as it retains the original shape and is the input for next phase, that is feature extraction phase of the proposed method. So after segmentation, like this is the glioma tumor. So here we can see that only wherever it is above 127, that is 128 and above, all the pixel intensity values are retained. Rest all are just merged as black. So here we can see the images. So next is the feature extraction step. So after the segmentation, the segmented image 512 by 512 image is split into 16 by 16 non-overlapping blocks. So this will result into 32 by 32, that is 1024 blocks of size 16 by 16. From every block, one feature is extracted and stored, which is the number of non-zero values in the block. So what are these non-zero values? In each block, the number of pixels having value 128 are counted, and this count becomes a feature. So total 1024 features are extracted for an image of size 512 by 512. So by achieving a compression ratio of 256. So this is the unique feature of our projects wherein we are compressing the image by 256 times. The features are stored in a file as well as for every input image, a 32 by 32 feature image is generated and stored. So this is how the feature extraction file looks like. That is, we have the glioma tumor, and here you can see initially all are zeros indicating that our background is black, and wherever the pixel intensity values above 127 are present, in that 16 by 16 block, the number of pixels are counted and that
Excuse
count
me,
is
ma'am.
held. Yes.
Yeah, sorry to interrupt. I just wanted to mention that you have 2 minutes of time left to conclude your presentation.
Okay. So here we can see the image size is reduced to 256 times. So by achieving a larger compression. So next is the classification. That is, now any random brain image is fed as a testing input for the model. So this image is subjected to all the steps mentioned above, and a feature matrix is generated. This feature matrix is compared with all the training data set. Where the maximum match is found, the image is said to belong to this class. So this is how classification is done. Here we can note that a large data compression occurs before the match is done. That is 512 by 512 image is now converted to 32 by 32 image, and the comparison is done with this compressed image. Hence, time complexity is reduced by 256 times. So this is the performance accuracy, how we are measuring. That is, training accuracy is measured. So this is the general formula, like true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So we are getting 100% accuracy, and but validation accuracy 77.92%, and including both we have achieved 97.34%. So next is comparison of accuracy with other models. So if we compare with CNN model, VGG19 model, infection V3 model, so here training accuracy achieved by CNN model is 87.63 and validation accuracy is 60.15%. And similarly for others. And our proposed model has training accuracy of 100% and validation accuracy is 77.92%. So validation accuracy is also almost similar, or it is crossing some of the models as shown here. And we have achieved total of 97.34%. So again, in a graphical form, it is represented here. So time complexity is big of m by n square, where m is training images and n is the image size. So feature matrix comparison reduces complexity by 256 times. So conclusion is a special domain-based model with reduced time complexity and high accuracy is proposed here, and its efficiency and performance surpass traditional CNN, VGG19 and Inception V3 models for brain tumor classification. And retention of the original image shape helps in further analysis. So these are some of the references. Thank you. So any questions?
Yes, ma'am. One question that when you're doing compression of 256 to 32, then in that case, is there any chances of losses of the data? Like when you're compressing the image from 256 to 32, in the compression process, are there any losses of the data also?
A loss in the sense only we are retaining the 8-bit plane, But as a result shows like validation accuracy is 77, that means a little bit of loss may be there. So that we have to improve actually. Because in training, we have seen that it is 100% accurate because there are no chance of losing any information. So whatever information we have extracted in for the training image, it will be retained. No loss in that, but only maybe as we have considered only the 8th bit plane. But anyway, 8th bit plane retains its information. No problem for that.
Okay, ma'am. Over from my side.
Oh,
Thank you, ma'am. Thank you, sir. We'll be
Oh,
moving towards
thank you.
our next presentation. Our next presenter is Arnav Rahul Jade, who will be presenting his paper on cloud-based plant health monitoring system.
Good morning, sirs, and my participants. Am I audible?
Yes, sir, you're audible.
Let me present my screen.
Sure.
Is it visible?
Yeah, it's visible.
Yes. So, good morning again. So, my presentation is based on cloud-based plant health monitoring system. We have made it with four friends from the college and under guidance of our project guide, Miss Amruta Pabrekar. We are from the EXTC department of our college. And this project is basically uses IoT and ML algorithms to use utilize agriculture as a service to further our sustainable development goals. So, what is the challenge in traditional plant health monitoring? As we have seen, like if you see farmers have to manually check for diseases present in a farmland, it is very time consuming. They have to check every plant and uh, if there is any delay in checking for any diseases, then the problem can grow to other areas of their farmland to other farmlands, and that is something that we have to avoid to get better crop yield. Again, chemical application is also a problem in this area because if you use unnecessary amounts of chemical, you damage the soil, you damage the future prospects of the land. So we wish to counteract with quicker analysis of diseases that are present in the farmlands. So our solution, it is a paradigm shift in plant diagnosis, as the title suggests. So we want to use ML algorithms, basically AI, and IoT devices, so microcontrollers that are integrated into the internet to quickly monitor the diseases in real time and get an accurate description of what diseases are present in a plant and uh, provide action suggestions that can be done so that uh, the plants can be saved. So uh, this is our literature survey that will be found in a paper. So a paper was written by Mr. Pragnesh Kulkarni and his associates. What he was, used a random forest classifier. That's a algorithm uh, that for image processing, and he used achieved an accuracy of 93%, but he didn't use it as an agriculture as a service. There is another paper which introduced for it's a agriculture as a service model, but and uses fuzzy logic, but it has not been public yet as of yet. Mr. Demille and his associates also did work on this machine learning for plant disease detection. So what we have found in this the gap in this papers is that they are not actually combining agriculture as a service with IoT and AI for use for the farmers who are uh, who have to be the user. So we are using a convolutional network for to gain and train our images and gain an accuracy of 99.7% from our data set. So this is a overview of our architecture, cloud-based architecture. We are using ESP8266 microcontroller due to its support for Wi-Fi and sensor connectivity. We are for taking parameters parameters like soil moisture and temperature and humidity of the area for data. Uh, we are using a CNN model that is based in the cloud for detecting the diseases, so that no onboard onboard the classification is needed, which saves resource on the user end. Uh, we have made a GUI for the cloud access that can be used to easily send images to the cloud and get output of their data. And it's a dashboard, and it tells you real-time statistics that have been collected by the ESP8266 microcontroller. So data acquisition, the sensors we are using is DHT11, DHT22. These are basic temperature and humidity measurement sensors. They have been attached to a ESP8266 microcontroller along with an YL69 soil moisture sensor. This will tell us about the soil, the moisture in the soil that is present, that can be used by our system to activate water pumps if need be. Cotton leaf dataset has been sourced from Kaggle. It's an open source data on cotton plant leaves, which include 3 diseases and a healthy sample. So that and we also aim to take contributions from the users as the data for future expansion of our data set. So left to right, these are the 4 samples. On the left is the bacterial blight disease that affects the leaves of the cotton plant. On the second is the curl virus. Third is fusarium wilt. These are all diseases found in cotton plants in India. The fourth one is a healthy example of a cotton leaf. And so what we do is we are using a simple sequential convolutional neural network with 6 layers what that can that are used to train and validate their validate their learning for better accuracy. First, it is the algorithm. What the algorithm does is it resizes all the images to 256 by 256 pixels of images. So for standardization of the data, then various transformations are done to the data for like edge cases, and noise reduction techniques are using like max pool convolutions, and a max pooling is done for extracting as much as data as much data as possible. And
Excuse me, sir.
yes,
Sorry to interrupt your presentation, but you have got 2 minutes of time left to conclude your presentation.
okay, sir. Sorry, I'll be quick. So this is how our CNN model works. So again, CNN architecture. This is a little detail about what we are doing. Uh, we have differentiated our data into training and testing. We have 80% of the data for training, 20% of the data for testing and validation. We are again using 3 diseases for our purposes. It is we are softmax activation function for, and we are again so again this is our data of the last 15 epochs of our training. We used 50 epochs for training to gain maximum accuracy. We tried getting higher, but we achieved less accuracy on that. Generalization. We have tried the data to be as concise as possible. Overfitting has been avoided, and there is very lost convergence between training and the validation of the data of the CNN model. We have again created a GUI. This is on the top picture. This is what we see when you enter our website. We are using a Blink platform for getting data from ESP8266 microcontrollers and ESP32 cap. And when you enter the data, when you enter your authentication token, you are getting real-time statistics on the GUI. So this is a sample. Like if you upload an image, this is a sample image from our data set. If you upload it, the model is predicting what disease it is suffering from, and we are adding images to the training data. We have set a limit where after a certain amount of images have been uploaded, the data is retrained for even higher accuracy gains. Our system is not perfect. We want even higher accuracy. We need even bigger data, and for that we are testing out methods, and we have to again have multiple IoT devices that we can use for uh, for progressing in our goal. That's all from my side. Thank you. Any questions?
Yes, one curious question from my side,
Yes,
that
sir.
when you are working on this project, are you directly utilizing the images as your GUI, whatever you have shown in the PPT, you are getting the photo manually from the camera, right? So are you converting in your model to grayscale, or are you directly processing the image as it is?
No, sir. We are using color photos. Our model doesn't convert it into grayscale. We are like the first step is cropping our images to 256 by 256, so that the main data, that is the leaf, has to be the main focus. It recognizes patterns using the convolution layer networks. They are extracting data from it, and then we are training our model on that data.
Okay. So, have you tried any images from a normal farm where a whole farm is visible and multiple crops are getting captured?
So unfortunately, sir, we don't have a cotton farmland near us, but we have taken images from Google, cotton images suffering from diseases from Google,
Okay.
which are not in the data set, and we have run our algorithm on that, and it is giving us correct results. We have at least, like, out of 10 times, at least 9 times it is correct. I can assure you that.
Okay. Okay. Thank you.
Thank you, sir.
That's it from my side.
Thank you, sir. We'll be moving towards our next presentation, and the next paper to be presented is on farm tech, enhancing agricultural equipment utilization with machine learning based price prediction. The paper will be presented by Srushti Pawar.
Hello, good afternoon.
Hello.
Am I audible?
Yes, ma'am, you're audible.
Okay, I'll share the screen. Is it visible, sir?
Yes, ma'am, the screen is visible. You may proceed with your presentation.
Okay. So good afternoon, everyone. I'm Srushti Pawar, along with my co-authors from Shanankar Kachi Engineering College, Mumbai, and I'm here to excited to present our work titled Farm Tech: Enhancing Agriculture Equipment Utilization with Machine Learning-Based Price Prediction. So, first of all, agriculture is the backbone of our Indian economy. Almost 70% of India's population relies on farming. Yet, many farmers struggle with underutilized equipment, unpredictable cost, and limited access to smart technology. One major issue they face is the high cost and low utility of farming equipment, especially in off seasons. Another is the lack of transparency in pricing when buying, selling, or renting used machinery. That's where FarmTech comes in. It is the machine learning based platform designed to predict equipment prices, improve utilization, and build a sharing based economy for agriculture tools. So, we conducted a comparative analysis of several machine learning models used in the similar research. XGBoost in Satyapati achieved 92.66 accuracy. Support vector machines had the best R square of 95.27%. Random forest outperformed many models with an R square of 94.85. Here, R square means the accuracy. Linear regression, lasso, and ridge also showed solid performance when data as well as well processed. This survey guided our model selection process and inspired the structure of FarmTech. Our goal was to develop a dynamic platform where farmers can share, rent equipment, especially during non peak seasons. The system can accurately predict prices using condition, brand, usage, and other parameters we'll consider. An integrated payment gateway ensures seamless transaction. Here we have used PayPal. The system supports a variety of equipment types like tractors, harvester, fertilizer spreaders, and seeders, etc. The platform has four. This I'm sorry. This is the proposed system comparison, where first we'll compare the model's accuracy. Your gradient boosting has the most greater accuracy, that is 94%. Here is the model execution time, where we can see the random forest models take more time for execution compared to linear regression and gradient boosting. Here are several parameters while training and testing the model, like MAE, MSC, and RMSE across the all the models, and here we can compare all the three models. So here is the model. Has four core modules: user interface, that is clean, supplier dashboard where equipment can be listed, rented, and price predictions are made. The third one is customer module, allows user to search for machines nearby using geolocation and rent them to the farmers or the suppliers. Then the admin panel, where we allow users to search for machines nearby using geolocation and rent them, and oversee the system, also monitor rentals. Our architecture combines machine learning, React.js for frontend, Node.js for backend, and MongoDB as the database. So the tech stack we have used, as you can see, is the front end React.js, backend machine learning, such as deep learning, Python. ID is VS Code, API testing and documentation, such as for PayPal integration, Postman, virtual control, Git and GitHub, and the database is MongoDB for storing the user's data. This is the data and model selection, where we have seen such as uh, we have taken the data set from cardego.com and used transfer learning from Kaggle dataset. That is, this was the data from car, but we have, as we have used transfer learning, we have encoded the features that will support our system. So the features integrated were vehicle age, price, fuel type, kilometers driven, and the number of owners. The categorical variables encoded using one hot encoding, such as the categorical values such as fuel type, diesel, petrol, or any other thing, CNG, can be converted to numerical variables, so that it can be used for model training. 80% training and 20% testing split was done for the data set. Your model selection, linear regression, three of them, random forest and gradient boosting, where we can see the iterative improvements and highly accurate model was gradient boosting. Here we have done hyperparameter tuning for both of them using different number of estimators. Train, test, and split impact. The data was divided into three different split while training and testing, such as 90-10, 80-20, and 70-30. Here we found it during the gradient boosting 80-20 train and split. We found the highest accuracy, that is R score 94%. This is our GUI for this is the GUI for users that can use for admin panel. We have also another features like for uh, gaining seats or something for the consumers, and this is a machine price prediction GUI.
Sorry to interrupt, ma'am, but you have 2 minutes of time left to conclude your presentation.
Yes, sir. So the challenges of the application were authentication or validating the right farmers or user on our website. We also face language barrier as in rural areas most of the languages used like Hindi or Marathi or something else. Uh, then scalability. Our system is now just a prototype, but if we want to scale it on a higher range, uh, it is a bit difficult. And also integration. The future scope is like, as I said, it is just a prototype. We need to enlarge it, and there is geolocation. Like we can search for nearby farmers for renting or sharing our equipments. Uh,
Hello, ma'am.
so while concluding, yes, sir.
Have you tried real-time data for your model
Yes, sir.
after you did all your evaluations, right? So for the GUI, what you have showcased, have you tried real-time data apart from whatever data set you have in your model?
Yes, sir. Actually,
So,
one of our co-authors, Mansi Jadhav, uh, has a farm of her
okay,
uncle. So we just contacted him and listed out all the things or the uh, drawbacks of the system and also communicated with him. And then we have cited our presentation.
okay. So did you test your model after that from the farmer who was there in contact with you?
Yes, sir.
Okay, so were the results satisfactory as you predicted, or there were some challenges, like out of 10 cases, 8 were working or 2 were failing or something like that?
Yes, sir. There were some challenges as the prices can be dynamic. We cannot like look for the real ones. It is
Okay,
just a prototype. So if we integrate it with the real time project, it may work.
okay. So thank you. That's all from my side.
Okay, thank you, sir.
Thank you, ma'am. Thank you, sir. Now we'll be moving towards our next presentation, and our next paper presentation will be presented by Ilakya R on the paper title IoT-enabled real-time monitoring for predictive maintenance in DC motors.
Good afternoon, sir. I'll share my screen now.
Yes, ma'am.
Sir, is it visible?
Yes, ma'am. Your screen is visible and you may proceed with your presentation.
Okay, sir. So, good afternoon. I'm here to present a paper IoT-enabled real-time monitoring predictive maintenance in DC motors. And I have three other authors with me. So the main problem that we have focused on this idea is the industrial machines undergo wear and tear over time, and this things leads to the unexpected failures. So usually, whenever the machine breakdown happens, it can cause to the long downtime, and it will impact on the productivity, and it will of course impact the revenue also. And there are some traditional maintenance methods that are existing. So those are inefficient, which are reactive and time-based maintenance. The reactive maintenance, the type is basically whenever the machine undergoes a failure, then the response, they look after what went wrong. So that is the reactive maintenance. And time-based maintenance is there will be regular schedules and the machines will be monitored on the regular schedules. So the both of these methods have drawbacks. So that's why we need a real-time predictive maintenance that is will focus on the machine parameters and will monitor it on every time, and whenever the fault is going to occur we will know in beforehand and we will be able to rectify it, so there will be no downtime. So we are trying to implement this approach. And the problem statement that we are focusing is we are trying to monitor the health parameters such as vibration, sound, RPM, and torque values. So based on these parameters, we are basically trying to know the health parameters, and from these parameters inputs, we will predict whether the machine is in healthy state or in the faulty condition. And we will use machine learning models to do the fault classification and also to predict this anomaly detection. So by this way, we can avoid this traditional maintenance methods and we will know in prior hand. And this is the objective. We are implementing an IoT based system to monitor the parameters, and we are therefore monitoring using these three parameters as I specified here to have the health parameters. And our proposed system here, we have implemented a DC encoder motor along with these sensors, and these sensors will collect the real-time data, so which will be sent to a microcontroller. Here we have used Arduino Nano for the processing, and the Arduino Nano microcontroller will transmit the data to a system using serial transmission, and a Python script which will be running on our PC will upload these values into a real-time database, that is Firebase. And our Firebase will fetch these incoming values, health parameters, and it will have, we can integrate it with, I have used Google Colab. So I have my machine learning trained models, 3 models we have done, a random forest and support vector machine and logistic regression. So these 3 are the models that we have trained. So when these incoming new values are detected by the model, and if the model classifies it as faulty or healthy based on the binary values 1 and 0. So 0 indicating healthy and 1 indicating faulty conditions. So whenever the fault is triggered, that is 1 is found, this trigger, we have an automated alert system integrated with this Firebase. So a trigger will be sent and an alert notification will be sent to the maintenance team members about the issue and what parameters is on wrong values. So by this means we are sending an alert through both means as SMS and email. So the maintenance team will receive these instant alert notifications. So by this way we can quickly intervene if there are some motor failures occurring, and by we can say this is an optimized maintenance way. So this is our proposed system diagram. From motor, we have got sensor values and it is sent to platform, and through serial transmission, it is uploaded to PC, and from therefore it is going to database. And from the data collection, the data analysis is done, and our machine learning models will predict if it is faulty. And whenever the fault is triggered, the alert notification team will see and the maintenance team will receive it through the SMS and email. So this is our overall proposed system. And to collect the values, we have tried from 3 different data sets. The first thing is software.
Excuse me, ma'am. Sorry to interrupt. Just wanted to mention that you have 2 minutes of time left to conclude your presentation.
Okay. So from software Simulink, we have simulated the DC machine and we have got the parameters. So the FFT analysis is done for the vibration, and here we can see the healthy conditions and faulty conditions. So this way the speed and torque graph is for the healthy, and that varying graph is for faulty conditions. And this is the hardware prototype that we have done. So we have used motor and we have used driver, and we have used a sound sensor and vibration sensor. So we have collected dataset values from the hardware setup also. So this is the dataset from software Simulink and from hardware. And from here, we have train set and test set, and we have trained the model and the prediction is done. So the predicted target, you can see that it is zeros or 1 based on the healthy and faulty values. And the first model that we have done is random forest. So it showed an accuracy of 98.45% with this. And also we have taken the dataset from Kaggle also. So these models are done for the values from that Kaggle dataset. And this is for the logistic regression. And it has an accuracy of 98.18%. The same, and this is a support vector mission, and it has an accuracy of 98.45%. So if we compare three different models, the highest was both random forest and support vector mission, but our random forest model predicted more fault values also correctly. So we can say the best method among these three were random forest, and these are the values being transmitted to Firebase. And also these are the results sent to the maintenance team whenever the fault is detected through email and SMS. And also we have integrated this with an HTML page, so where we can see the values for the varying time interval. And also we have integrated this with our ThinkSpeak platform, so we can observe the patterns of each parameters. So it will know us in predicting the patterns. And in future work, we are trying to explore more of deep learning models also. And we can also use edge computing, and rather than using Arduino basic microprocessor, we can go with more high computing devices as well. And references. Thank you.
So the prototype which you showed in the presentation, so
Yes, sir.
have you taken any patent, or for the idea what you have shown in this paper, have you taken copyright for the same?
No, sir. No, we didn't do it.
Okay, if whatever results you have showcased, if they are genuinely working, and if you do a real-time check for the data for your hardware, you can, this is my suggestion
Okay,
as
sir.
a session chair, that you can file a patent also if the model is working as per what you showed in your PPTs.
Yes, sir. Thank you, sir.
Just one curious question in the results, that
Yes, sir.
the accuracy was same for SVM and random forest,
Yes, sir.
98.45.
Yes, sir.
So any difference you can highlight between both, that among the both, which is better as per you?
Sir, according to me, the better model will be random forest, because when we saw the recall value for SVM and random forest, the recall was low for SVM. So the model didn't predict the fault values more accurately on SVM. Comparatively, it was better predicting the fault values on random forest. So for the more accurate model, for predicting both healthy and faulty, the accurate model will be random forest.
Okay, thank you.
Thank you, sir.
So thank you, sir. Thank you, ma'am. We'll be moving towards our next presentation. The next paper to be presented is Modeling, blockchain-based comprehensive web framework for maintaining health records. This paper will be presented by Yatish Garat.
Hello, sir. Am I audible?
Yes, sir, you're audible.
I'll share my screen. So, good afternoon, everyone. I am Yatish Bharat, and I'm going to present our final year project entitled as Modeling, a blockchain-based web framework for managing electronic health record. So, the project was carried out under the guidance of Mr. Mandar Ganjapurkar. So, the team consists of me, Yatish Bharat, Atharva Makore, Yash Kasar, and Yuvraj Gage. So the abstract for our project is Meddling, which is a blockchain-powered platform designed to secure, store, manage, and share medical record. It tackles key problems such as data privacy breaches, fragmented records, and inefficient hospital systems. So with the help of smart contract, we automate these operations. So smart contract basically are lines of code which is used to enhance the data integrity and improve the coordination between the healthcare providers. And then we have the main four objectives of our project is to boost the medical record security using blockchain, empower patient with control over their health data, and facilitate smooth and secure data sharing between the patients and doctors, reduce the cost and error using smart contract for automation. And we for literature review, so we have referred for three papers, and more importantly, because we explored various papers on blockchain in healthcare. So this helped us understanding the existing solutions and the gaps which were particularly faced during the use of blockchain. So we used Ethereum blockchain for our project, and also decentralized data storage. So problem definitions. Traditional healthcare system which struggle with securing sensitive data such as a patient's record or any big celebrity records, we have to secure it from the unauthorized access or breaches. And records can be like fragmented across the clinics and hospitals, so which creates inefficiency. So and also there is a lot of risk of data manipulation leading to insurance fraud and incorrect treatment. So the scope of a project. So the main scope of our project is to secure health records using blockchain, allow the patients to manage who can access that data. So the patient has full control over that data, enable encrypted and seamless data sharing across the providers, digitalize and streamline the healthcare workflows. For the next, the technology stack. We have used various technologies such as blockchain. For blockchain, we have used Ethereum blockchain, and we have used Node.js for the backend, HTML and CSS for the front end, then Solidity for smart contracts, MetaMask and Ganache for development and testing, and IPFS, which is a decentralized file system, interplanetary file system. We have used IPFS Kubo in particular for this project. So the our platform supports benefits such as efficient communication between the doctors and patient, and full privacy control over patients, elimination of paper records. So everything is electronically based and making the system eco-friendly. Then we have our proposed system. So we have basically two entities, patient and doctors. When they meet in person, so the doctor can provide the patient with an unique number, which is an HS number, through which the patient can access the platform, which is Medilink, and he can give the user access to a particular doctor he met. So that particular doctor will have his health records of the patient he gave the HS number. So basically HS number is the number which the patient gives to the doctor. So the patient will type in the HS number through which they can connect to that particular doctor itself. And then we have the design and flow of diagram. So basically we again have two entities which are patient and hospital. Hospital consists of entities like doctors and diagnosis. So patient gives a unique key, which is the HS number, to the system through which they can access the data in the blockchain. So the patient first has to create an account, so where he can upload his reports which were collected which were collected uh, from the doctor. So he can then communicate the reports from Medilink where to that particular doctor itself through blockchain. So we have administration who can uh, see all this, and two entities which are the users, I can say. Doctor and patient are the two users, and admin which grants the access to the doctor through their unique ID. And we have your implementation. So this is our Ganache dashboard where we get local Ethereum test networks. So through which we can use Ethereum cryptocurrency to manage the accounts and the Ethereum cryptocurrencies through which we can do transaction, where these transactions are minimalistic to carry out a particular action, such as to upload or to log in, we need a particular Ethereum amount. So we have created a MetaMask account where we have basically three accounts: one for the doctor dashboard, one for the patient dashboard, and one for the diagnostic dashboard. So this is the IPFS shell where you get connected to the IPFS server. So basically, IPFS Kubo has these various nodes, server nodes, where your data gets bifurcated within the nodes. So it gets distributed into a peer-to-peer connection. So it is not it gets distributed and it is decentralized, so you don't need a particular server to store all your information, so which enhances your data security.
Excuse me, sir.
Okay.
Sorry to interrupt, but you have got 2 minutes of time left to conclude your presentation.
Yeah, yes. So we have here like the two users, doctor and patient. So the doctor will have his wallet public address, which is the same public address as which is provided by the Ganache, and the HS number and password and specialization. So a patient will also have his own specific HS number, a unique identity number through which he can be identified, and then the patient will have the dashboard. Patient will have the dashboard where he can view his profile, view his record, upload his past record, and grant permission to a particular doctor. And the doctor will have his dashboard where he can view his profile, view the list of patient under his batch, and then he can view the patient's record as well. So the results are like this. So this is our home page, and so on the left hand side, you can see a doctor registration page, and the records which are viewed by the doctor after registering. He can view the specific records, and this is the patient report upload page. So where the patient can upload his reports and share with the particular doctor. So this is the patient dashboard where he can view his profile, view his records, upload his past records, and grant permission to which particular doctor needs to see his records. So conclusion and future scope. So conclusion is we have enhanced security and privacy. So blockchain, which is a decentralized and immutable, guarantees the transparency between the patient and doctors health records, and gives the patient full control over their data while preventing unauthorized access. So also seamless integration and automation. So we have used technologies like MetaMask, Ganache, Solidity, and Ethereum to streamline secure data sharing, consent management, and automate transactions through smart contracts. So for scalability and efficiency with Ethereum strong network and Node.js for backend operations, the system supports high-speed, scalable, and reliable healthcare data management and interactions. So for future scope, we have to build in so this basically is a prototype, right? So for future scope, we have to build in a major connection between the hospitals and the patient, where we can use the real-time patient data as well, and the which can network through a particular organization or a particular hospital. So also to improve the healthcare delivery, you can strengthen the patient autonomy by increasing system efficiency and transparency. So that's it from my side. These are the references we used as well for our paper, and thank you.
Yeah, one question out of curiosity for your paper is you use backend as a blockchain, right? And where you integrated it successfully. So, any challenges that you faced while implementing the blockchain for this mechanism that you have proposed in the paper?
So yeah, sir. Basically, we were trying to implement it using Ethereum blockchain only from the start. Uh, so our sir basically suggested to go with Hyperledger, but we chose Ethereum because it is way much easier to understand and implement on a prototype and beginners level, so you can actually get insights of what blockchain is. And we also face challenge while connecting our data to a decentralized our blockchain data to a decentralized system. So we done it through IPFS Kubo.
Okay, thank you.
Thank you, sir. Now we'll be moving towards our next presentation. And our next presentation will be presented by ML Hiranya, who will be presenting her paper on optimized wireless multipliers using approximate adders with ALU error correction.
Okay. Am I audible?
Yes, ma'am, you're audible.
Is my screen visible?
Yes, ma'am, the screen is visible.
Okay. Good afternoon, everyone. I'm Manipur Lakshmi Hiranya, and I'm here to present our project titled Optimized Wireless Multiplier using approximate adders with ALU error correction. So, coming to abstract, to give you a quick idea, the main goal of our project is to make arithmetic units like multipliers more efficient in terms of speed, power, and accuracy. We use Smith adders in a 4:2 compressor in a wireless multiplier, and then we placed it inside a reversible AL. On top of that, we added error injection, detection, and correction using parity check and XOR logic, which is also comes under the application of it. So the result is a fault-tolerant, low-power architecture that deals with for ideal AI, DSP, and even for quantum computing. So, while introducing, we all know that how important adders and multipliers are in digital systems. But precision-based circuits usually consume more power and area. That's when where proximate computing comes in. Gives us a little room to trade off accuracy for big gains in power and speed. So by integrating that into the reversible ALU, we not only improve efficiency, but also make the system more fault tolerant and especially useful in modern applications. So the problem identification, the problems that we are going to solve and the problems that we are faced. Basically, the traditional wireless multipliers that we are using and that are being used in beside is to use a lot of power due to switching activity and have higher delay due to serial stages. Also, conventional ALUs and reversible ones are limited by inefficient multipliers. So, is our aim to design something that's lightweight, fast, reliable, and with compromising too much output quantity. So, we came up with a proposed solution, which is incorporation of five approximate adders. So our five approximate adders and a 4:2 compressor and integration inside it a reversible ALU. So we also coming in a application we also added a parasitic mechanism to detect errors and a simple XOR based application logic to fix them. So this approach helps us achieve high performance and efficiency while keeping the error under control. So our objective in this are like to develop an energy efficient Alice multiplier, to develop a reversible ALU, and to reduce power delay and area for the and performances of added size. So the tools we are used while doing this project is Verilog HDL, which we use Cadence, Vitsuso, and Verilog for our simulations. And we choose 90 CMOS technology because it's a good middle ground, realistic, easy to work with, and also supported by most tools, perfect for our academic researchers like ours. So while smaller nodes like 45 nm and others are offer better performances, they are harder to simulate, more prone to leakage. The thing we use like 90 nm was a smart and sustainable choice. And this is the methodology that we have used, like selecting of an approximate adder and integrating into the wireless multiplier, and then a 4:2 compressor in the partial phase reduction, and also integrated and also then plugged into our reversible ALU. We studied and their error probabilities like power, also tested how the error correction logic works. When we purpose injected, so these are the results when that are occurred while trying each of the proximate adder, where AA2 exhibited the lowest error probability and AA3 and AA4 has highest errors. So like we have checked the probability error of sum and the probability error of vary. And these are the performance analyses that we had done using the 90 technology, where we have compared with the adder to the approximate normal adder to the approximate adder, which was built by us. Like we have known about total area, total power area, and delay. So, and coming to our application, we have injected like an error injection to the approximate adders. In this slide, we are showing you the real example of error injection and correction for different adders. So, uh, uh, in- for instance, the LU produced an error like this, and the correction happened with minimum delay, and the system stayed even after 50 microseconds, which is great for real-time applications. So this is the performance comparison. We have 5 adders perform AA1 to AA4 at the lowest delay over 4997 picoseconds. AA3 has the highest at 5004 picoseconds. So again, depending on whether you prioritize the speed and accuracy, you can choose the best option for system. And we have some references. We refer to a number of IEEE papers and approximate computing, Wallace multiplier, and also the 4:2 compressor and reversible ALUs was used in our paper. So we can say that this gave us a strong foundation about our design. And on bonus, we wanted to show that it supports sustainable development as mentioned. Like before I wrap, I would like to quickly mention how this project aligns with sustainable development goals. First, it supports affordable and clean energy, enabling low power computing. Then it also contributes to industry innovation and infrastructure, optimizing scalable hardware. So our design can be used in IoT devices, smart sensors, and edge AI platforms, reducing power usage, and also for the hardware phase, so which is a step towards the green and sustainable electronics. So I wanted to conclude that we built a efficient and fault-tolerant Wallace multiplier using approximate adders and reversible logic. This is ideal for AI chips, embedded platforms, and resource-limited devices. Also supports sustainability, which is increasingly important in tech. Okay, thank you for all listening. I will be happy to answer any questions if needed.
Just one question. You said you have variations from AA1 to AAA5, right? So can you say in layman term what is the exact difference in this the 5 variations what you have created?
Have used it like differently. We have constructed the approximate adders using in different terms uh, like summing upon and using the things in different manners. We have designed these approximate adders in a different way by giving different connections. So to check what is the result that is coming upon.
Okay, because in the results we can see AA1 is having the same result as AA4. AA2 is having the same result as AA5. So, how will you differentiate the results on the same slide? Yeah, this one only. That the performance for adder is also 5,000, right? So all the three are giving same. So what variations you have made internally to the A1, A2 That I just wanted to understand.
So these are the results that we got after doing an analysis, like after injecting an error our present application. Uh, before that, the things are different. Basically, while we build these approximate adders, but after error injection, the results which are similar here.
Okay, delays are same for these adders. Okay. Okay, fine. Thank you.
Thank you.
Thank you, sir. Thank you, ma'am. Now we'll be moving towards our next presentation. And our next presentation is on the paper title, Sustaining Community Workforce Through E-Governance, Addressing Motivation, Retention, and Public Health Resilience. The paper will be presented by Deepa Unni.
Good afternoon, everyone.
Good
Am I
afternoon, ma'am.
audible? Am I audible?
Yes, ma'am.
Let me share this. Okay, good afternoon, everyone. I'm Deepa Unni. I'm here to present my topic, Sustaining Community Health Workforce Through E-Governance, Addressing Motivation, Retention, and Public Health Resilience. This paper is co-authored by Dr. Murali Venugopalan and Ms. Sanju Kaladharan, and we are from Amrita Vishwavidyapitham University. Moving on to the abstract, this is basically about community health workers' sustainability. Okay, we all know they play an important role in delivering health to the public, but actually these programs often fail due to the impracticable expectations, lack of proper planning, and also effort required to implement these activities are often underestimated. In many countries before the COVID-19 pandemic itself, we have used many digital technologies to address these kind of issues. But limited research is there to discover the role of e-governance in addressing the sustainable community health workforce. So this paper, through this paper, we tries to bridge this gap by proposing a model, e-governance enabled sustainability model for CHWs. Moving on to the introduction, it was after this Alma Ata declaration of WHO in 1978, which brought a major change in the concept of health. Over the last centuries, it was just confined to doctors and hospitals only. But now, according to this declaration, governments are responsible for a particular population's health. And WHO and Global Health Workers Alliance, they have recognized already CHWs as a vital module who was required for the progression towards the Millennium Development Goals. They are actually the effective leaders and change agents who can bring a lot of change in the population's health. And in various countries, CHW's delivery services are regarding maternal and child health, HIV/AIDS, mental health, tuberculosis, malaria, etc. When coming to India, we have accredited social health activities. They are considered as one of the largest government-led community-based CHW program with around 1 million trained CHWs. And they are mainly focusing on women and pediatric health service delivery in the rural areas. Now, coming to the contextual background of this paper, for strengthening the public health system, it is very essential, especially in a resource constrained system, it is very essential to maintain the sustainability of these kind of programs. And the issues that we face are actually the high turnover rates, low motivation, unstable workforces, and these issues actually affect or pose a danger to the long-term efficacy of the CHW program. So it is in this context we bring e-governance. So e-governance is basically the use of digital technology in governance and delivering public services. And through this, we can address all these challenges by improving the efficiency, transparency, and accountability. And when talking about India's e-governance program, it seeks to enhance the provision of services with the help of ICT, information and communication technology, and through various projects. The research gap, what we found out is that various literatures indicate the importance of digital health tools in enhancing the sustainability of programs. However, a comprehensive framework integrating these tailored to CHW program remains limited. So to address this gap, we have tried to come up with a model. Now, the major objective of the study is to propose a model leveraging e-governance to improve CHW motivation, enhance retention, and strengthen the sustainability. Now, integrating e-governance for the sustainability of CHW program, we have actually in India, we have implemented e-learning modules for CHW via the National Health Mission digital platforms, whereby it has enabled self-paced training and assessment. Even we have AI-driven chatbots and mobile-based micro-learning tools, which can enhance the training outcomes by providing real-time support and interactive learning experiences. Moreover, we have mobile health applications to track the CHW activities for real-time performance metrics, then blockchain technology to enhance the transparency in this, incentive disbursement, and we have AI, integration of AI and predictive analytics to identify the patterns of attrition rate, the workload distribution, etc. So these are the major literature highlights. I've just included a very few. So studies have conducted in many countries and many challenges are faced by the CHW like high attrition, inadequate training, performance evaluation, etc. And many e-governance interventions they have adopted like incentive tracking, digital learning modules, AI-based monitoring, etc. And what are the sustainability outcomes they got? So by intervening all these, the retention is improved, the skills are enhanced, workforce allocation has become more efficient, which ultimately all led to job satisfaction of the CHWs, etc. Now, the workforce dynamic
Excuse me,
factors.
ma'am. Sorry to interrupt. Just wanted to let you know that you have to conclude your presentation in coming 2 minutes.
Yes, okay. So these are the workforce dynamic factors. So major thing is that unhappiness with resignations were found to be a leading cause, which was due to unhappiness with the work environment, severe workload, etc. So and here also mindful based training and EI helps them a lot to control their emotions and thereby improve the quality of care. So this is actually the conceptual model where the e-governance mechanisms helps to stay the CHW workers motivated, like because all these apps and this digital interventions helps to like incentive disbursement, then career growth and work-life balance, supportive supervision. It will lead to all these factors, and ultimately it can help in public health resilience and sustainability. And there are certain moderating factors also. Some negative moderating factors and positive moderating factors. This is how we have come up with the model. And the implications is that the government and healthcare institutions can integrate e-governance mechanism in a more structured manner. They can standardize online training modules. They can establish real-time performance tracking using mobile health applications. And in India, we have already e-Sanjeevani for telemedicine, Nikshay for disease surveillance, TB, etc. And then investing in interactive voice response system and mobile apps, then enabling remote consultation and implementing EHR. They are a great way to enhance patient care and community. The limitations is that it's purely a conceptual paper frame based on existing literatures and theoretical frameworks. It lacks empirical validity. And the study assumes that these mechanisms are accessible and scalable, but in low resource settings where there is lack of internet connectivity and there is a low digital literacy and technological infrastructure, in such situations, it may hinder the implementation. So to conclude, strengthening CHW programs through e-governance is not just a technological shift, but it is a necessary policy transformation. Governments and health agencies must prioritize scalable, accessible, and adaptive digital solutions to ensure a resilient and sustainable community-based healthcare system so that the needs of the population are met. So these are some of the references, and thank you for your attention, and I'm open to questions.
Ma'am, curious question out of the presentation that since I am from computer background and every solution that you have proposed is making the use of computer technology, right? So
Yes.
how we can ensure that the right now there is one buzzword called as digital wellness, right? So that whenever we are going for the e-governance, we are shifting from our manual techniques to a digital platform. So when we are bringing these policies, have you gone through any paper where we can ensure that with limited digital technologies, we can bring out this awareness?
Actually, interventions, use of digital interventions in healthcare, research regarding that is very limited, especially in Indian settings. That is what we found.
Okay, ma'am. No issues. Fine. Thank you.
Thank you, ma'am. Thank you, sir. We'll be moving towards our next presentation. And the next presenter is Mr. Moreshwar A. Mahale, who will be presenting his paper with paper title Tomato Leaf Disease Detection using fusion of Thepidis SBTC and Heraldic Moments GLCM features with machine learning algorithms.
First of all, good afternoon all. So now I'm sharing my screen. Okay, so today I'm presenting the tomato leaf disease detection using fusion of Triplets SBTC and heraldic movements JLCM features with machine learning algorithm with the guidance of Dr. Apurva Joshi ma'am. So today I am presenting this content in that what is the behind of motivation, literature survey, problem statement, objective methodology, advantage, what is their applications, timeline chart, and conclusion and references. So taking this topic, behind the motivation of this taking this topic, the crop health is essential to maintaining the agriculture community. Means you have see the I have added some screenshots in agriculture sector. The 3.8% in FY25 as per the economic the agriculture sector is the backbone of the Indian economy and forecast to grow 3.8% in FY25. And second screenshot, you can see the 47% of the population is depending on the agriculture. So that's why I'm taking the tomato leaf disease detection agriculture domain with the integrating machine learning algorithms. So before taking this topic, I have studied some literature topics as a best papers. Here you can see, after the study of all the literature papers, I have seen the limited certain of crops, extensive data set required, and all the authors and researchers are focused on same disease and same methodology use. So after that, this summary, I will be set my problem statement, that is a tomato leaf disease detection using a fusion of two feature extraction with the machine learning techniques. Uh, After that, I set three objective to research on this project. First one is to study of and analyze the tomato leaf disease data set. Second one, study of Thepes sorted block truncation coding. This is a feature extractions. And third one is to develop the hybrid feature extraction approach using fusion of TSBTC and GLCM. So we can start with one by one. Objective one, this is a study of data sets. So I have used plant village tomato leaf disease detection data sets. So in that total 1609 images, including disease in details like that bacterial spot, early blight, late blight, leaf mold, spectral monocysis virus, yellow leaf curl virus, and more. Include RGB or grayscale. So all the images are RGB, and total size of the data sets is 2 GB. Label or unlabeled in, so that is the label data sets, and total 10 classes in these data sets. So you can see the tomato leaf disease. Here are classification of the tomato leaf disease data sets with their disease, healthy, bacterial spot, early blight, leaf mold, spectral leaf, and target meat. This is a fungal infection of the tomato leaf, and here is a graphical representation of percentage. In this data set, how many percentage of the classes are divided. So you can see uh, objective is a study of TSBTC feature extractions. Um, First of all, I have said the TSBTC is a Theptes sorted block truncation coding. This is a global feature extraction techniques, and this is developed by the Dr. Sudeep Thepte sir. This is a pro vice chancellor of the Pimpri Chinchwad University, Pune. So how it will work? You can see the diagram here below. First of all, the image blocking. In that image blocking, divide the image into the small and non-overlapping blocks. After that, pixel sorting. After pixel sorting, we have done a thresholding. Used to threshold lower mean and upper mean. So what is the lower mean? In that average of the lower half of the sorted pixel intensity, and same as the upper mean, average of upper half of the sort pixel of intensity. And a binary breakpoint. After that, we have binary breakpoint generation. Assign 0 to pixel is less than or equal to lower mean, and 1 to the pixel of greater than upper mean. After that, the classification, uh, we have use the two feature extractions machine learning models for the disease detection and segmentations. So here, after applying the TSBTC on tomato leaves, so here we will get the how you can see feature extracted images. Uh, After that, applying the tomato leaf disease detection data set on the TSBTC feature exchange, so we will get this results. Here you can see we will get the random forest for 79.85 percentage after applying the machine learning algorithms on this data set with the help of the TSBTC feature extractions. And we have taken the in symbol classifiers, that is a 74.75 for the random forest, random tree, and J48. Here is the graphical representation of the our results. The third one is to develop the hybrid feature extraction approach using a fusion of TSBTC and JLCM.
Hello, sir.
Huh? Yes.
What is ACA in the previous slide?
1 minute.
In the
ACA.
top column of classifier, you have mentioned ACA. What is ACA?
Average accuracy, sir.
Okay. Okay.
Oh, yes. So
Please carry
we
on.
have taken the all average accuracy of the all the machine learning classifiers.
Okay, sir. Please carry on.
So this is our objective 3, to the fusion of TSBTC and JLCM. How it is work, you can see. First, JLCM is work as a gray scale image. After that, the numeric gray level. After that, the co-occurrence matrix. In that co-occurrence matrix, it will be depend on the neighborhood element or pixel size. So after it will be taken with relation with the neighborhood. So it will be a pixel adjacency. After that, the global normalization. We will get the JLCM result. So we can the next step is the global normalization. In that global normalization, every value is divided by the total number of occurrence, and results is that probabilistic instead of the raw constant. Uh, so you can see the my research diagram. You can say this is a tomato data set. After that, we will take the fusion of TSBTC plus JLCM. This all the global and local feature extractions. After that, applying the machine learning classifiers, and we will get our output for the tomato disease. So how it was work? So you can see the TSBTC diagram here. Sorry, tomato leaf disease diagram here. Uh, we have taken the TSBTC features as per the T1, T2 to T5. This is a 2 array, 3 array, 4 array, and 5 array. It means it will be divided into 2 array means 2 blocks, 3 array means 3 blocks, 4 array means 4 blocks, and 5 array means 5 blocks. After that, we will take the JLCM, G1, G2, G3, G4. This is the features that I have mentioned, the G1, G2 to G4. And after that, I will be merge all the TSBTC features with the JLCM features. And after merging, I have applying the machine learning classifiers or models, you can say algorithms, to fusion of the tomato leaf disease. So after applying the machine learning classifiers on the fusion results, so we will get the 68.92 as a
Hello, sir.
average. Yes.
Sorry to interrupt you. Just wanted to mention you have got 2 minutes of time left to conclude your presentation.
Okay, sir. So after applying the jail's fusion method on that tomato leaf disease data sets, so we will get the average accuracy that is 68.92, and the in symbol accuracy is 70.1, and average accuracy is 78.15 for the random forest, LMT, and linear regressions. So this is a graphical representation of the result table. And this is my timeline that how I got my one by one objective of the research, their advantages, economic benefits for the farmer, yearly detection, optimal fertilizer use, after the some application also have smart farming system, agri-tech startup mobile application for the farmer, and agriculture research. So conclude is the system integrate a new feature extraction. As I say, till now no one can research on this. No one can use the TSVTC and the GLCM fusion method on this topic. So this is my novelty to uh, for the smart farming. And yes, this is my references. And thank you, sir.
Dr. Shailesh, are there any questions or inputs from your side?
Am I audible?
Yes, sir, you're audible.
Okay. So just one curious question that when you have done the fusion of these two techniques,
Yes.
have you filed any copyright or patent for the same?
No, sir, but currently we are thinking about that. Till now, we are not patent yet, but in future we can go for that because we are also research on for better accuracy. Yes.
Okay. And one more thing, in the first method, you showed the example till 5 arrays, right?
Yes,
So
sir.
maximum how many arrays we can go for using that method?
Sir, till now we can go for the 40 array, 40. We will go for the 40 array.
Okay. Okay.
Yes.
Thank you.
Okay. Thank you, sir.
Thank you, sir. Now we'll be moving towards our last presentation for the session. And the last presentation will be presented by Vanishri Pabalkar, who will be presenting a paper on analyzing airline sentiment in a multilingual Twitter landscape via vectorization and ML models. So this concludes our session 5C. I sincerely thank our authors for their excellent presentations and contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I request everyone to stay for a minute. I also thank our session chair, Dr. Shailesh, for chairing the session. A token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir.
Thank you to the whole team. Thank you.
Now, I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. Thank you all. Stay safe and take care.